All right, so what happens if HX is not HX, but like X2, we have two halogens? This is still going to follow that 1,2,1,4 dynamic. So we're still going to get addition of something to the second and third carbon positions, regardless of whether or not the second and third carbons are secondary, tertiary. And again, for these asymmetric dienes, go back and see my video talking about how we should end up generating two kinetic and two thermodynamic products. We're just going to focus on the one. So the nice thing is that we add something like X2. It's still going to follow the mechanism we expected. Now, the X2 here can't be with light. If we go to free radical, actually what we get are additions to allylic carbons. So we put a carbon, chlorine here, chlorine here, chlorine here. We would start adding to the double bond. When we have these double bonds and we just add the halogen as is, we get the 1,2,1,4 addition. The big difference here is that our 1,2,1,4 additions, 1 and 2 and 1 and 4 are both going to be chlorines. But there is something that makes this way more complicated. So even though it really simplifies in the sense that your kinetic product is going to be the 1, 2. So there's your kinetic, and your thermodynamic product. Draw this one down here. So there's your kinetic, and your thermodynamic is the 1, 4. There is an additional problem here. So when you add chlorine to a double bond, they always add anti, right? So what we expect for the kinetic product is to have both one wedge, one dash, and we would get two products, one where one is wedge, one is dash, and then we flip the dashes and the wedges. What about the thermodynamic? So for the thermodynamic product, we will go through a carbanion intermediate. It is going to introduce stereochemistry effects. So in principle, you could work this out in terms of figuring out that for the thermodynamic product, should these both be wedges? Should they both be dashes? Should one be wedge, one should be dash? Short answer is because you're kind of doing this weird hopping, I think they end up both being wedge or both being dash. But the fact I just told you, because I think I don't actually know for sure, should give you a tip off to how much we're going to really worry about this. So with these thermodynamic and kinetic products for X2s, we're not going to worry so much about the stereochemistry, even if we're generating stereocenters, because honestly, it's just getting too complicated at this point, and we don't want you to lose like the forest and the trees here, because not only do you have the 1, 2, 1, 4 with this asymmetric, so you've got to consider both kinetics and both thermodynamic products. You also have to consider the stereochemistry of what you've just made, which will probably give you 2 more, so that's a total of 8 products, if not 16 products. We're not going to go to that level of depth. So this is kind of this with the HX versus the HX radicals, asymmetric, dienes. That's as complicated as we're going to get here. We're not going to worry so much about the R and the S's. Because you're going through intermediates, in principle, you can form cis-trans products as well. We're probably going to lean more towards the trans products. Don't overthink it. This is just organic chemistry too. But yes, for those of you who wonder about why, particularly when I'm getting chiral carbons like here, and why I'm not drawing in that stereochemistry, way too much detail, way above this course. Again, what we're going to focus on here, if you have an X2 addition, 1, 2, 1, 4 addition, both 1, 2, and 1, 4 positions are chlorine, and it's going to behave just like that.